Right, our problem is that we would like to find how many different ways could we go from one point of a network to another point. So as an example, we want to go how many ways can we go from school to home and vice versa. You cannot backtrack. We can just go one way. So you can think over here, we could go up here, we could go across, up, and there. So if I was to write that down, and I'm going to be really quick, I'm not drawing every single bit and piece here, and we've got the house. But then you're thinking, well, hang on, instead of going all the way up, so we can change color, instead of going all the way up here, what if we went across here? And so then we go up and there. Okay, so now we're going up a little, across, up, and across. And I hope you're then going, well, what if we didn't go all the way up here? What if we went across there? So that's another option that we've got. You now see how many ways you could come up with to do that. So pause the video, see how many you can do. Follow your boxes here using your grid, your graph paper. It's a lot easier for you, so you can see the clear difference between all of them. Let's see how many you can get. How many did you actually find? Let's see how many we've got. One that we have prepared earlier. Okay, we go over here and you can see, did you get 8? 1, 2, 3, 4, 5, 6, 7, 8, right? 8 different ways that we can actually find here. So just by trial and error we can get, now if we look at some of the questions that are coming our way, if I asked you now do trial and error and how many different combinations you can get with these, you're going to be there a while, and you could get up to, you know, over 20 possible different ones. And do we really want to draw those? The answer to that is no. So this is where this thing called the algorithm comes in. And we'll just prove it with this one, and we'll see. Proving doesn't mean just do it once. We'll do it a couple of times and see if it works. So what we say is, well, how many ways, if we went that way, right, how many ways have we got to get to this node here? And clearly there's only one. And same to go the other way, right, that way, there's only one way to get to that node. To get to this one, you can see that we could have gone this way and this way, or we could have gone that one and that one. So that means there's 2 ways to get there. And if you notice, if I actually add up the diagonals, 1 plus 1 gives me 2. And that's how we're going to get the gist, basically. Now, what about this one? There's only one way to get there because we're going up 1. We cannot go up here, 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 and then there because this step is actually backtracking, and that's not permitted. So when it's just up there, we sort of do the slide and it goes up there by 1. So now we're asking ourselves how many ways to get to this point. And you can again trial and error and go, well, we've got 1, 2, we've got, so that's 1, 2, and then 3 going that way. And hey presto, again, if we add up the diagonals, we get that same answer of 3. And that's what we basically keep doing. Again, what to get to this one, we do the slide. So we're just sliding over. And now this is the diagonal of these, so that's going to be 5. Okay, this one, you can't really do anything, so we're sliding up. That's 3, and 3 plus 5 is 8. And that's the different listings that we have there. So when we're talking about how many we do, we're going to use this algorithm. For the exercise that I'm asking you to do, exercise 15B1, for question A and B, I would like you to actually draw them out and do it by trial and error. So exercise, oops, sorry about that. Exercise 15B1, question 1, A and B, you do those actually writing them and listing them all, just like the example that we did there. But for C and D, we're going to do the algorithm, okay? And then you'll get more practice in B2. So stop the video, go and have a look and see if you can do A and B, compare with the answers to see that you got the same number, and then come back to the video as we're going to do C. Pause it, welcome back. Right, we're going to these nodes here. So remember, you're sort of going in that direction, so no backtracking. So to get from here to here, it's a 1, and then we're adding up these diagonals here, and we get the 2. There's only one way to get to this point here, right? Remember, it's just bang, straight there, because you cannot go here, 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 and then here, because that's backtracking. So just, we do the slide, that's 1, and then again our diagonal here, 1 plus 2 is 3. Now again, think about it, you can prove that it's 3, because you're going 1 there, we can do, that's a second 1 there, and of course the third one goes that way, and that's it. So this method works. To get to this one, again, it's only 1, because you can't come this way, because then you're backtracking. Hope this is starting to make a little bit of sense. 3 plus 1, right, gives you 4 for that point. What about down here? Again, you're sliding, that's 1, 3, slide. Now, to get to here, 1 plus 3, that's going to be 4. What about this one? 3 plus 3 is 6. 10, 6 plus 4 is 10, and then we end up with 20. So imagine if I had asked you to write down all the different paths, you would have been there and doing it 20 times. Now you see this one is D. You try and do it without. If you get the right answer, fast forward the video. If you don't get it, well then you're listening to me. Okay, that goes 1, 1, 1 plus 1 is 2. We're sliding down here, and we get the 1. Over to this way, 1 plus, right, the diagonal, we've got the 3. Only way to get to this is again straight down. It's only one way without backtracking. 1 plus 3 is 4. Okay, what about here? So again, to get to this point, there's only 2 ways, because we can go 1 there and then 1 and there. So 2 ways, because that's your slide, and then we're adding 2 plus 3 gives you the 5. Here, that's also a 2. 5 plus 2 gives me 7. And what about over here? So we get to this point, it's 5. Then to get to this point here, again, that's your slide. That's only 5 as well. 4 plus 5 is 9, and 9 plus 7, 16. Check your answers. Hopefully that is a winner winner chicken dinner. If you'd be so kind as to finish off, try question 2, that's nice. With B and C, so with B for question 2, we sort of have to do some of the ones in here that will help you when you've got some conditions that apply. So we'll just practice a few more. So if you could practice A, B, C, D with the algorithm, and then we'll do one of the harder ones. So this is now exercise. Here's B2C. Hopefully you did okay with so hopefully you did okay with A and B. So here we go. Remember, we're going in that general direction. So we start off, same things that we did last time, 1, 1. We can only go one way there, we can only go one way there, and 1. Okay, so now we get our diagonals, because again, we know there's 2 paths to get there, 1, 2, and we get that by adding the diagonals. 1 plus 2 gives me 3. And 1 plus 3 gives me 4. This one we can say is 3. And if we're looking at this one, right, 3 plus 3 gives me 6. 4 plus 6 is 10. We've now got our eye on this one, that box, right? The 3, remember if we get, there's 3 ways to get to this point. Well, when we go up by 1 there, there's only 3 ways to get to that as well. So now if we're looking at that bigger box, How many ways can we get to this point here? Again, that's only one without backtracking, so 3 plus 1, right? 3 plus 1, I get 4. Only one way to get to here, all the way along. So 4 plus 1 gives me the 5. We're nearly done. Right, this one here, we've got all these different ways to get about, so 10 plus 4, 14, and 10 plus 5, 19. 19 ways to get from S to F. All about the slide. Again, please stop the video, try and do D without any assistance, and then just skip along, click, click, click along the video if you don't need to listen to me. But if you get stuck, you can have a look. Again, feel free, turn the volume down. So now we're going in that general direction there. So 1, 1, and again, only one way to get to there, You might be wondering, what about these little bits here? But again, you can only go from there to there because any other way, that bit there, you've backtracked. So no go. It's just 1, 1, 1. Okay, so 1 plus 1, that one's going to be 2. However, how do we get to this one here? So again, one way to get here and only one way to get there. We can't go this way because again, that would be backtracking. So it's just that. And then we've got 1 plus 1, so that gives me 2. How's that sound? To get to this point here, okay, that's going to be a few ways. It's not just slide with the 1 because I could come down here, 1, and remember, to get there, that's one way to get there. So that point is also a 1, which means 1 plus 1, that's now 2. And now with this diagonal, 2 plus 2, we get this one is 4. 1 plus 4 is 5. Hopefully we're doing okay here. What about this? Now, is this point here, slide the 5 or slide the 4? Not sliding the 5 because that would be backtracking, okay? We're coming this way to get to this point. There's 4 ways, and then that would mean there's only 4 ways then to move on because there's no other way that you can go. So that's 4 as well. Okay, to get to this point, we'll get there in a minute. It's almost like a puzzle, right? To get to this one, we actually need that point there. And we have to work backwards. So 2 plus 2, this one here will be 4. 4 plus 4, that's going to be 8. And then that means this one is also, it has to be these two added together. So 12, which makes that one 17, okay? Again, you might be asking, why aren't I sliding that one to be 8? Because yes, there's 8 ways to get to here, but then I can also come this way, okay? A funny 8. Okay, 17, working away here, what have we got? 4 plus 1, that gives me a 5. If it's 4 ways to get to here, then that's also going to be 4, which makes this 8 plus 4 makes that one 12, which makes that one 17. And aren't you happy that you did not have to draw all of the different methods here because there's 34 of them? Again, please make sure that you are doing this by yourself. Just copying and doing what I'm doing isn't going to help you get that understanding. We'll keep going, a bit of a change of back to the blue, I feel. How many paths are there from A to L? Should be used to this by now. So, by the way, big tip, if you're drawing these by yourself, make sure they're big. The smaller the diagram, the more likely you are to make a mistake. So A to L, we're going 1, 1. Oh, that's a bit small. Let's make that bigger so we can see that. 1, 1. So 1 plus 1, that gives me, that's 2 there. Slide the 1. 1 plus 2 is 3. To get to this point, there's only 2 ways. So sliding up, that becomes 2. as well. How many ways can I get to C? The sailor went to CCC, so that's going to be 1, and so now 2 plus 1 gives me the 3 here. Again, 1 there, 3 plus 1 gives me the 4, and then you've got that diagonal there, so it's 3 plus 4, 7 ways, okay? 7 ways to get there. Now, when we have some restrictions on, please can you go and read the example? It's basically using zeros to represent that you can't go down a particular path, right? So if we have a look here, I think we've got poor old Sally, Mustang Sally. Okay, we've got Sally in the middle, and follow this, have a look. Do you agree with what they've done? Maybe copy this down yourself and do it without looking at the example. But we're looking at now B. Alvin must visit Sally along the way, so he has to go through Sally. So basically you do the same thing, okay, but notice here, once we get to that bit there, that isn't a 1 anymore, it's a 0, because if you went down that path, you're not going to end up going via Sally because you can't backtrack to get to her, right? So we use the zeros to help us block a path. Similarly, if we look at C, Alvin must avoid Sally. So what happens there is if you're avoiding Sally, you actually put a 0 at that point. So go through, have a careful read of the example, and then come back and see how you can go with question 2. All right, I will probably leave it there because I think that's not too bad, and you probably listened to me enough. Feel free to send me in a question if you don't quite get the answer or you get something wrong.